one of the things that I think is that no matter what students do in this course and what resources they use, there are lots of Khan Academy videos, videos with the text. There are other resources available on the internet and in the textbook that will teach you how to do dimensional analysis and how to do calculations. But one of the things that I wanted to show today was some of the things that I think are not in any of the programs, and that maybe you haven't seen them either, Kevin. So I want to show you some of that. Okay.
Yeah, sure.
So let's just see what happens here. I'm gonna pin this video here. So this is up here. All right. So for starters, Kevin, Rebecca wanted to know whether or not you even knew what the word dimensional analysis was, or what that meant. Is that a common term for you, or do you think?
No, it's not. I actually had to look that one up when I saw it going through the textbook, just kind of remembering, oh yeah, that's something important.
Yeah, it is important, but I don't know whether everybody refers to it as dimensional analysis or not, or some people might refer to it as conversions and that sort of thing. So I like to thinking about dimensional analysis because I care about analyzing the dimensions, right? And the dimensions are the things that go after the number in some measurement, right? It could be kilometers, it could be grams, it could be milligrams, but whatever that's the dimension part. And then as I was thinking about it, there are ways in which I think our students already know how to do this, but they're not necessarily cognizant of knowing how to do it. And so there are 3 key points I've got when it comes to dimension. And I want you to, and feel free to butt in and ask questions here, or ask me to clarify if I do something that doesn't make any sense to you. But the first one is that often some formula is given to you, and you don't even know that it's given to you. So that's the first point. You don't, sometimes you may not know what's available to you, but it's there. And I'll come back and I'll explain that in a second. The second point is that the equals sign is your friend. You can do a lot of things if you pay attention to what an equal sign, you recognize what it actually means. And the third thing is that often you multiply by 1. And when I look at videos on the internet or I read textbooks, these 3 points aren't ever made for you. And so I want to go through these 3 points and see how you react to them. Okay? So, first one. Kevin, how fast are you allowed to drive on the highway?
Speed limit in illinois is 60 miles per hour, 70 miles per hour, I believe.
And you've got to tell me, by the way, when I start to go off the screen here, because I'm so focused on my hand. So you said 70 miles per hour, right?
Yep.
And I'm telling you, you know the formula for speed. And because it's given to you in the thing that you know. Speed is miles divided by hours. So if you know a speed, the dimensions that are behind that will tell you what the formula is.
That makes sense, yep.
Yeah. So if you know this, you know the formula. And that's good, right? You don't have to memorize the formula. You know that one. What about, here's another one. What's the molar mass of water?
H 18 grams per mole.
Sure, 18 grams per mole. And you can get that by going, oh, Rebecca's home. So you can get that by going H2O, and depending on where we are in this course, when you're looking at this video, this might be easier, it might not be hard. But you know, you've got one oxygen, and so you've got 1 times 16 for the oxygen, and you've got 2 hydrogens. So you've got 2 times 1.01 for the hydrogens. So if I go 16.00 equals 2.02, add those together, 18.02 grams per mole, which is exactly what you just said, right?
Yep.
So we know, or you knew, that the molar mass of water is 18 grams per mole equals the molar mass. So just like the speed, you know that molar mass is equal to mass divided by moles. It's given to you. You may not have seen it in there, but you know it. Right? So in terms of, right? So sometimes when you're given something like that, you'll be able to find it. And so we just did molar mass equals grams divided by moles, and we just did speed is equal to miles divided by hours. But it could also be kilometers per hour, or it could be meters per second, but there's one that you know. Here's another one. Work is equal to force times distance. Any idea what force is measured in?
Newtons, if I remember correctly.
I think it is, and I'm not exactly sure how much a Newton is, but it's certainly, it's Newtons times a distance, which might be meters. Oh, meters. And so work is a certain number of Newton meters. So if you're told the amount of work is 25 Newton meters, that might remind you. So if in some question you are asked, or you're told, hey, the work equals 25 Newton meters, that might remind you that it's newtons times meters. Pay attention to the dimensions. If you pay attention to the dimensions on these things, you don't have to memorize a lot of the formulas. They will come to you.
That's a good point. I never really thought about it like that.
Yeah, well, it gets even better, because if we look at one that in this course we won't encounter until much later in the course, but some of you have seen this one. Some of you know that for gases, some of you have seen this equation for ideal, right? And maybe you do know, or maybe you don't know, that pressure is measured in atmospheres. You might know that volume is measured in liters. N is the number of moles, and T is temperature in Kelvin. So what would the units for R be?
Well, then you would just have to solve the equation for R, right?
Yeah, exactly. So there's a couple of things. Yes, if we solve the equation for R, but it also tells you that R has to relate atmospheres, liters, moles, and Kelvin in some way, right? Because that's all of these things have to be part of it. So this brings us to the second point. The second point is the equal sign is your friend. So I've got PV is equal to nRT. An equal sign really means equal. It means that this thing on this side is the same as this thing on this on the right-hand side. So as long as you do the same thing to both sides, you're in good shape. So what I want to do is we wanted to find out the units for R, right? So I want to get rid of the moles and the temperature on the right-hand side. And so what I'm going to do is I'm going to divide this side of the equation by N, and I'm going to divide this side of the equation by N. And my moles are going to cancel out. And I'm going to do the same thing again. I'm going to go PV over N is equal to RT. And I'm going to divide the right-hand side by temperature, and I'm going to divide the left-hand side by temperature. My temperatures are going to cancel out, and my R is going to be equal to PV over NT. And what do I know? The equal sign is my friend, equals. So here's my pressure, atmospheres, liters over moles, Kelvin. All of these things have to be equal. And so what is the unit for R? It's liters, atmospheres, moles, Kelvin. And so if you look up a value for R is equal to 0. I got to get this straight, 0.082057 liters, atmospheres, moles, Kelvin. So that's the equal sign is your friend. What do you think of that, Kevin?
I think that's another great way to look at it. And at the same time, it goes back to the first step, because a lot of tests, sometimes you're not given an equation. Sometimes you're not given PV equals nRT, but sometimes you're given the variable or the constants. Like you're given that value right there. 0.08 something. I can't really read it, but you're given the units, liters, atmospheres over moles, liters. So if you don't have the equation, you can work backwards too.
Yeah.
In case of that.
Yeah. So I don't think that this is shown to you in most courses and in most texts and in some of the resources. And so I think this is a something that we may be able to provide to our students that's a little bit different. I want to move on to the third point, okay?
Yep.
So the third point is that often you multiply by 1. Is that on screen? Yeah.
Yep.
And I don't know about you, Kevin, but I'm guessing that everybody in our class knows what happens when you multiply by 1. What happens when you multiply by 1?
It stays the same.
Yeah.
There's a fancy math term for it, a law or something. Yeah. I don't really remember it.
I don't remember that part either, but yeah. Multiply by 1 question mark. That's a question mark over there. It may not look like a question mark, but it is. And that's a 1. Okay, so here's 3 times 1. What's that equal to, Kevin?
3.
Thank you very much.
No problem.
Yeah, exactly. 16 times 1 is 16, right? Here's another one. Here's 3 times 1 over 1 equals
3.
Right? 16 times 1 over 1 equals 16, right? That's what we're good. So far, so good. Give ourselves a couple exclamation marks because we're doing so well here. All right, so here's where this is important in chemistry. Well, this is important in life first, then we'll do some chemistry. So if I have 24 eggs, and I want to know how many dozen eggs is that? Or how many dozen eggs? Right? That's what our question is, something along those lines. All right, so here's the question, most important thing you got to ask yourself. In answering this question, how many dozen, did I change the number of eggs?
I don't think so, no.
I mean, I just want to know how many dozen it is. I still have 24 eggs, right? So I haven't changed the number of eggs. Did I increase the number of eggs?
Nope.
Nope to that one too. All right, we could write nope over there. Circle it because we got it right. Did I decrease the number of eggs?
Nope.
Nope. So whatever I did to those eggs is just like multiplying by the number 1, right? Because I didn't increase them or decrease them. I didn't change it in any way. So whatever it is that I did. Now, when I first wrote this question, 24 eggs is how many dozen? You knew what the answer was, didn't you? If I go 24 eggs times, how many dozen eggs do I have?
2. You have 2.
I better have, in the end, my answer better be 2 dozen eggs, right?
Yep.
And I got to multiply it by something that doesn't change my number of eggs at all. I'm multiplying it by this thing that is 1. And what is the thing that is actually equal to 1? Well, you know, and I bet you all of our students know that it is 12 eggs is 1 dozen eggs, right? This thing, sure, it has the number 1 and 12 in it, but what does it really mean? It really means the number 1, because it comes from some ratio, something where it says that a dozen eggs is exactly the same thing as 12 eggs. So the top of the numerator and the denominator here are actually the same thing.
Yep.
So 24 eggs. I can cancel out my eggs. I multiply 24 by 1. It's 24 divided by 12 gets me 2. I end up with 2 dozen eggs. All right. So here, this part is really multiplying by 1. Okay, ready to take it up a notch?
All right.
Okay. So the question is, how many seconds are in 303.5 days? Is that on screen? Yeah.
Yep.
And we'll add an extra 0 on there. 3.50 days. Okay. Am I increasing the number of seconds?
Nope.
Am I decreasing the number of seconds?
Nope.
What am I doing?
You're just multiplying by 1, just like you said.
Yeah. So I'm not adding any time. I'm not subtracting time. So adding time? Question mark? Nope. Subtracting time? Oh, subtracting? Nope. So I'm going to start off with the thing that I'm given over here, 3.50 days. And I'm going to stick it over here. I better end up with seconds over here. And almost everybody in this course can do this so easily, but it might be a good idea to formalize it a bit. So I've got to get from days to seconds. Give me some things that are equal to 1 that I can use in there, Kevin.
So how many hours are in a day?
Okay. Okay. So I think a day and hours, right? My days will cancel out, so I put them on opposite sides. I think it's 24 hours in one day.
Yep.
What else?
There's also 60 minutes in 1 hour.
Right. So I want to put hours down here and minutes up there. And I know it's 1 hour is 60 minutes, right? And again, equal to 1, right? I haven't added any seconds, haven't taken any seconds away, just expressing them differently. And so then I want to go from minutes to seconds. So I better have seconds up here. And I better have minutes down here. And I know that it is 60 seconds in 1 minute, right?
Yep.
So days and days will cancel, hours and hours will cancel, minutes and minutes will cancel, and that will leave seconds, which is what I want. And I did this math before, and I got 302,400 seconds.
That sounds good.
And then I thought, well, hey, I started off with 3 significant figures here. I better have 3 significant figures here. So I went 3.02 times 10 to the 1, 2, 3, 4, 5 times 10 to the 5 seconds. What do you think of that?
Multiplying by 1 makes it sound a lot easier.
Kind of, yeah. I don't know. I mean, people who are experienced chemists and experienced scientists end up being able to do this very, very quickly and don't think about it in this way anymore, right? Because they've internalized it. But it was only maybe 10 or 12 years ago that I started thinking about it this way. And it made it easier for me to understand why I was doing it. That I wasn't increasing the amount or decreasing the amount. I was really just multiplying by 1. So in this course, eventually, we will take like grams or mass of a reactant and determine, is that still on screen? Yeah.
Yep.
And determine how much product could be formed. But often, if you just pay attention to the dimensions along the way, and you pay attention to thinking about whether you're increasing an amount or decreasing amount, which you probably aren't, and that you're multiplying by 1, it can help. It could be helpful as you're trying to solve some of these problems. Yeah. So if you just monitoring the dimensions, paying attention to those 3 factors, and can make a big difference in your ability to answer these kind of questions.